Hello, and in this video, we're going to explore our first category of energy, kinetic energy. So kinetic energy is the ability to do work because you're in motion. So any object in motion can do work, can exert a force, can push or pull on some other object for some distance. Here, we can see an example of how motion can push on an object for a distance. So we've got a little toy school bus here and a little toy fire truck. And when I put the school bus in motion, it has the capacity to exert a push on this fire truck for some distance because of the fact that it's moving. Here's another example where I've got two little toy cars tied together with a piece of yarn to show a similar thing. When I put the big red car in motion, once it takes the slack out of this string, it can pull on the little monster truck, exerting a pull for a distance, thus doing work on the monster truck. So that's the kinetic energy of objects as a whole. But there's also kinetic energy within objects. Any object that has a temperature, i.e. everything, has its molecules moving around at random inside of it. Now, if it's a gas, they can move everywhere. If it's a liquid, they're a little more constrained. But even in a solid where the atoms are roughly held in place, they still are moving around a little bit. Here's a little animation that shows a little bit more detail exactly what I mean. So here we have water in its solid ice state at minus 127 degrees Celsius. So that's 127 degrees Celsius below its freezing point. And you can see that we have a block of ice. The molecules aren't moving around very much, but they're still moving. And then if I go and add some heat to it, we'll talk more about all of this later, the ice will melt until ultimately we are in a liquid state. And here in the liquid state, you can see there's this average motion of all the molecules moving around and jiggling around. They're still somewhat confined to the different, to the bottom because it's a liquid, but they're moving. And then the ultimate expression is, if I raise the temperature here, you can see 156 degrees Celsius, and the molecules are just sort of bouncing all over the place. The key takeaway is that even within a substance, even within an object, you have motion. And so you have what you would think to be kinetic energy. So even within an object, you have motion. You have this moving around of the individual molecules, either all over the place as a gas or sort of confined to the bottom as a liquid, or rigid but vibrating around in the case of a solid. And that motion is still a kinetic energy. And that kinetic energy is still an energy because it's capable of doing work. It's capable of pushing on something for some sort of distance. Here I've got a marshmallow. Now, a marshmallow is a sponge, basically. It's full of little pockets of air. And when I put this in a microwave, go ahead, try it at home. It's safe, it's fun. The air in the little pockets will get hotter. And so the temperature will go up. In terms of our little animation here, what's going to happen is the gas is going to get hotter and hotter and hotter and hotter and hotter. And so the molecules are going to start moving faster and faster and faster and faster. I'm going to be increasing the average kinetic energy of the molecules. And when I put this marshmallow in the microwave, we will see that happen. So here I've got my marshmallow in a microwave. Let's turn it on. And as I add energy, increase the kinetic energy of those molecules in those little gas pockets, we can see
that the marshmallow is getting much, much bigger. It's pushing against the air for a distance as it expands. That's the distance as it expands. And it's pushing against the ambient air.
This concludes this video.